So this question is a t-test question, and if I scroll further down, then I can see that we have a t-test because we have two groups of people, program A and program B, and we're wanting to compare between the two. So the first question asks us to state the null and the alternate hypotheses for this test. So for the null and the alternate, when you're doing a t-test, the null hypothesis is always the same, and it's that the two means are equal to each other. So for the null hypothesis, we want the mean push-ups. Is it push-ups that they're doing here? Yeah. So the mean push-ups from program A is equal to the mean push-ups from program B. And then for the alternate hypothesis, there will be something in the question that tells me what they're trying to test. So it says that the trainer believes that program B is more effective than program A. So we're expecting the mean of B to be larger than the mean of A. So we're expecting that the number of push-ups people can do after completing program B will be greater. And then for part B, you're then asked to perform a t-test. And again, we can see there that we're doing the t-test on this information. So we're going to go to our calculator and we go to stats and edit. And you can see that I've typed that information in here. And then we're going to go to stat, calculations, tests, and then it's the two sample t-test that we want to do. So two sample t-test, we have the first list in list 1 and the second list in list 2, and then we need to make sure that we have the correct second or alternate hypothesis selected. Make sure that you always have pulled yes, and then we can calculate. And we can see here that our p-value looks a bit obscure to start with. It looks like 4.07, but we should be thinking at that point that that does not make sense. We can't have a p-value that is bigger than 1, and therefore the p-value would be 4.07. And if we can see here, it's actually times 10 to the power of minus 6, so it's standard form. So it's 4.07 times 10 to the power of negative 6, or 0.00, there's going to be 5 zeros there in total, and then 407. And that would then be your answer to 3 significant figures. And if we think about this, you can see we've moved it 1, 2, 3, 4, 5, 6 decimal places. So that's our p-value. And you're also asked to find the degrees of freedom. So the degrees of freedom is just the number in our list, which is 10. So minus 1 is 9. The number in our list is 10. So that's minus 1 again, which is 9. So therefore, the degrees of freedom are 18. You can also see on here, degrees of freedom equals 18. So you're just writing that down. And then for part C, we need to, based on the results that we've got here, decide whether program B really is better than program A. So part C is the conclusion to the test. Now, since the p-value is significantly less than the significance value, and it's a lot less, it's a very small answer there for the p-value, we therefore reject the null hypothesis, and you are going to accept HA. So always mention the null, whether you reject or accept, and then if you need to, you can mention the alternate hypothesis as well. And therefore, we should have a sentence there. We are in the applications course. Program B, so program B is more effective than program A. Okay, so the marking for this question, you have, for the first one, it is 1 mark for each of the correct hypotheses written. and then you have a mark for the correct p-value. Don't forget, do not just write 4.07. Think to yourself, that doesn't make sense, that's 400%, therefore double check this part here. And you have an answer for the degrees of freedom, which again, you can just read off from here. And then we have 1 mark for the reasoning, so this part here, and 1 mark for the correct answer.